Well, on this video, we're going to continue with our reptiles. You can notice that we're looking at lots of different turtles here and just beautiful, beautiful creatures. You can see all the different types from the alligator snapping turtle that we have over here in the center. There we go. To the sea turtles. You saw an example of the hawksbill sea turtle when we did our lab, the loggerhead turtle, the flatbill, a lot of these olive Ridley sea turtle, the leatherback. If you remember the lab that we did where you were keying out the different types of turtles, many of these you saw in that particular lab. So let's look at some of the anatomy and just some of the cool adaptations that you can see with the turtles. Starting off, obviously the turtles have a heavy shell. It's fused to their thoracic cavity. The top of the shell is called the carapace. The bottom of the shell is called the plaston. They have a shark beak that, if we got to do the dissections, you'd be able to see. And then they lay eggs. And right now, just recently, watching with the, we're on the quarantine with the coronavirus, I've seen beaches that are now being closed. We're seeing thousands of sea turtles coming up to these empty beaches and laying their eggs. And just what an awesome thing that is, so that in the midst of our quarantine, we're going to have a surplus maybe of some of these sea turtles that in the past have really struggled because there was no location for them to lay their eggs. So many times we talk about the term turtle and tortoise and terrapin, and let's just go over the difference between those. So a turtle is defined as any reptile that lives in a shell. A tortoise is going to be a turtle that lives on land. It can go to the water to drink or cool off, to get away from predators, but it doesn't live in the water. A terrapin is a turtle that lives primarily in the water. So you can call a tortoise and a terrapin a turtle, but the tortoise is going to be a land turtle and a terrapin is going to be a water turtle. So again, the top shell, and this is a test question, is the carapace. Each of the little squares is called a scute. The bottom shell is called the plaston. The side that holds the two shells together is called the bridge. Now, it's probably no surprise to you that I love cartoons. This right here is one of the classic Bugs Bunny cartoons. It's a cartoon where Bugs Bunny is racing a turtle and goes through all the tricks and how the turtle beats the hare. Well, during the cartoon, at one point you're going to see the turtle. He's just going to slip out of his shell and take a shower, maybe have little underwear on. But in reality, turtles cannot do so. And the reason for that is their backbone is fused into this carapace. So in order to remove a turtle from its shell, like you see on cartoons, you would literally have to rip out its backbone, and it would not survive. So a turtle cannot come out of its shell. When a turtle is young and small, it may be difficult to tell the males from the female. However, when the turtles get older, it becomes much easier. So the first thing you can do is you can look at the tail. Okay, the tails on the males are going to be much longer than the tails on the females. Additionally, if you're doing a dissection and you're looking at the tail to determine if it's a male or female, and you see a structure hanging out of the tail, it's a boy. Think about it for a minute, and if not, talk to mom and dad. But male tails longer than female tails. Another thing you can tell is the plaston here. The plaston on the male turtle is going to be more concaved, and on a female it is not going to be concaved, and that's for mating purposes. And then in some turtles you can also you can use their feet, and you can tell by looking at their feet and their claws whether or not they're male or female. And in those cases, that's going to be like the cooters or the paintage or the sliders, which are common turtles that are kept in captivity as pets. The male foreclaws are going to be much longer, and the females are going to be much shorter. If you were to take an art history class, or you were looking into going into architecture, you would see specific kinds of designs in various buildings. One of those is the buttress design. The flying buttress can be seen in cathedrals, and it strengthens the walls and it supports the massive weights of that towering cathedral. But one of the things I would like for you to be aware of is that man and all of our ingenious, we didn't come up with that. We stole that design from turtles. And so we can look at the turtle shell and we can see those fundamental architectural designs that are needed to strengthen buildings found within the turtle shell. God is just so awesome in his designs. So let's show you what the buttress design looks like in a turtle. Well, here you can see what that buttress design would look like in a building, but if you look, that buttress design is also found in turtle shells, and for the same reason, giving strength and reinforcing the shell for protection for that turtle. I mean, how awesome is that? Well, how about pillars? Pillars are also used to strengthen and to protect buildings, to give support. Well, the sides of the turtle in that pelvic area that's fused together inside the plaston and below the carapace, we find pillars present. So here we have what pillars look like in architecture and in a building, and then right underneath there's pillars within the turtle shell. Again, amazing God's design, and how we take that and we can use God's design. He allows us to see his design and gives us inspiration on how we can use that to better serve one another. Okay, and then finally we have the dome, that spherical or that partially spherical shell structure where it has great circles, formed triangles. I'm thinking of some different buildings in Memphis that as you go into Memphis that you'll run across these. But triangles are known in physics because they distribute the stress and they reinforce the structure. And it's a fundamental concept that we discuss in physics for engineering purposes of how can you reinforce a building? How can you make it stronger? We'll use triangles to distribute the stress. So here we have that dome structure. Well, let's come right on over to our turtle shell. And we have the dome structure and we have those scoots, and it's designed to divvy out the stress, to reinforce the turtle shell. And again, over and over again, I want you to see how amazing God is, and that he has allowed us to see his designs in such a way that we can use those, and we can use those for our benefit to help one another. I mean, it's just amazing. Now, I mentioned that turtles lay eggs, and they lay it in the sand, and they incubate in the sand, but the temperature of the eggs during their incubation determines whether you have males or females. So if the temperature is around 29 degrees Celsius, then when the turtles hatch, you should have a 1-to-1 roughly ratio of males to females. If the temperature gets higher, then you're going to have more females. If the temperature gets lower, you're going to have more males. Now here we have the green sea turtle, and the biggest conservation location for the green sea turtle is over at the turtle farm in the Grand Caymans. And if you ever get a chance to go to the Grand Caymans, it is really worth your while to see how they do turtle conservation. They release over 300 green turtles into the wild every year, and the turtles will typically have a tag on them. You can almost guarantee if you find a green sea turtle out in the wild, if you check it and it's tagged, 99% of the time it's going to be from the Cayman Islands. These turtles can grow up to being over 600 pounds. They can live for over 130 years. Now, the tag you would look for would be a yellow tag. And if you go to the caimans, you can also order turtle meat and try turtle and see what that tastes like. You can even order some turtle burgers. So I was talking to you a moment ago about the eggs and how they had these nests. And so this right here is what a turtle nest looks like. And again, it's the temperature of the nest will determine the ratio of the males and the females. At this conservation facility, they have turtles of all different ages as they grow the turtles up to where they are stable enough that they can survive in the wild. And so they take these eggs and they from the turtle nest, and they put them in bins, and you'll notice that they put dates on them, and they put the dates of the eggs in there because they have an incubation period. And so they keep these at a specific temperature depending on if they need more males, more females, if they need a 1-to-1 ratio. And so here you can see a close-up of an incubation box, and you can see the little eggs within there. At this particular time, this box was incubated at 82 degrees Fahrenheit. Now here I've got the temperatures in Fahrenheit. So 82 Fahrenheit would be the 1-to-1 ratio. Above 82 would be more females. Below 82 would be more males. When I gave you the 29, that was in Celsius. And then when I gave you less than 29 would be more males. Again, that was in Celsius degree. Above 29, that was Celsius degree for the females. Typically, the incubation period for these eggs would be anywhere from 55 to 60 days before hatching. Now, after that 55 to 60 days, the turtles hatch. Out in the wild, they would have to climb up through that 3+ feet of sand. In those incubation boxes, they're going to have to climb up through the sand. Now, the extent that the mother nurtures the baby turtles is that she builds the nest. Once she's laid the eggs, the baby turtles are on their own. And so many of the turtles, once they're hatched, they climb up through the sand. Then they have to make it from the sand back to the ocean. And that's the part where they're the most vulnerable. That's the part where a lot of predators will capture the turtles. And so while there may be hundreds of turtles that hatch and are making their way towards the water, only a handful actually make it. And so these right here, now these are about 6 months old. These are some green sea turtles over at the incubation area, and they were just so beautiful to see. These guys have quite a ways to go before they would be ready to be released out into the wild, but absolutely beautiful. Okay, now if you read this bottom, yes, some turtles can breathe through their butts. Now, like most animals and reptiles, turtles do have lungs, and they use those lungs to breathe air through their mouth and nose, through the trachea down to the lungs. But in a few species, they have a pair of sacs that are located around the cloaca area, which is the tushy area. It's where the intestines and the bladder empty out of. And so what they can do is they can suck water into the cloaca, into those pockets, those chambers, and then those pockets are lined with veins, and then the turtle can absorb the oxygen from that water into their blood. And so yes, some turtles can breathe through their butts. So how do you tell the difference between an alligator and a crocodile if it says see you later or after a while? Okay, seriously, the way you tell the difference between an alligator and a crocodile is if we look at our alligator here, it's going to have a very broad snout, and the teeth right there are very cone-shaped. If we come over here and we look at the crocodile, it has a very narrow snout, and then you're going to see the teeth that will be visible protruding on the outside of the mouth. Now, I also want you to know that these are the only reptiles that have a 4-chambered heart. Now, this is a picture of me in the Everglades. This is a caiman. It's fairly small, but the caimans can reach up to lengths of 6.5 to 8 feet long. As far as the caimans are concerned, they are very closely related to the alligators. And then the main difference you would see are just very subtle things within the skull area, just some differences in the fusion of the skull area, and then some differences that you would see in the plate, the armor. More specifically on that ventral surface or the belly surface, as far as how the armor is located. But just a cool little guy. And again, if you ever get a chance to just get out in nature on vacations and get to see God's creatures and His creation, it's just beautiful. And I think the more you see these animals, just the more in awe you can be of God as the creator, and just what artistry that He had in His creations. Finally, dinosaurs. Dinosaurs, to be honest, I took paleontology in college, and a lot of the classification of dinosaurs is messed up. They have put wrong dinosaur heads on wrong dinosaur bodies and such. Dinosaurs are not around for us to have absolute answers. So we find bones, they try to put them together. Many times the bones are separated, or they're crushed, they're broken apart. But as of right now, dinosaurs are classified as reptiles. Their bipedal stance or their quadrupedal stance, they classify them as reptiles. Some individuals want to classify them more closely with birds because of the shape of the hip, and the hip area being more similar to birds. But as of right now, dinosaurs are classed as reptiles, with an ongoing debate of, are they closely related to birds? Are they extinct birds? Whatever the classification ends up being, remember that's a man-made classification where we're trying to take God's creation, and we are trying to put that in man-made boxes for us to be able to understand. And we have to realize that God's creation is still above our understanding. However, you can see references of the dinosaur in the Bible if you look at Job 40:15, and they refer to the dinosaurs as the behemoths.